Concept 36B is all about the volume of a pyramid and cones. Volume of a pyramid is equal to 1/3 times capital B times H. Now, this part is very important. Capital B in this situation stands for the area of the base. So in order to find capital B, we have to do a little calculation. We actually have to find the area of our base. So in this situation with this formula, it will depend on the shape of your base. Okay, so if we have a triangular base, then we need to use the formula for area of a triangle. If we have a rectangular base, then we need to use the formula to find the area of a rectangle, and etc. So an example here, it says to find the volume of this pyramid. If we look at our base, here we can see that it forms a triangle, and we know that is 1/2 times base times height. So this is going to be our capital B in our volume formula. Write our volume formula as volume equals 1/3 times our capital B, which is going to be this entire thing, which is 1/2 times our base times our height times the height of our entire pyramid. So now we need to plug in these values. So we have 1/2 times 1/2. Oh, sorry, not 1/2. This should be 1/3. 1/3 from our formula here. 1/3 times 1/2 times the base of our base. So we need to use this 6 times 6 times the height of our base. So just the height of our base, which we know is given as 4. Close the parenthesis. Now this height on the outside is the height of our entire pyramid from the top down to the bottom, which they give us is 9. So that is the base that will go on the outside. Now you should plug that into your calculator exactly how I have written it. So with the parentheses, you should type in 1/3 times, open parenthesis, 1/2 times 6 times 4, close the parenthesis, times 9, and you should get 36 centimeters cubed. The next bit of this concept is finding the volume of a cone. The formula for volume of a cone I have already written is 1/3 times pi times radius squared times your height, where your radius is the radius of your base and the height is the distance between the bases. So we need to rewrite our formula. Volume equals 1/3 times pi. Our radius here is 3 squared times the height, which is from our apex in this situation down to our base, the straight line, 4. We will not use 5 because it is the diagonal. We want a straight line from the apex down to the base. Now if you plug that into your calculator, again in terms of pi, 12 pi centimeters cubed. This is in terms of pi, meaning that we have multiplied the 4 times 3 squared times 1/3, and we have not put pi into our calculator yet, so we include that when we write our answer. Now if it asks for your answer routed to the hundredths place or a specific decimal place, you would then multiply 12 times pi to give you your decimal, which you should get something along the lines of 37.699. Or if you want to round to one decimal place, we could do 37.7, and it would still stay centimeters cubed. So both of these answers are equal and both are correct. Now the next problem is asking us to find the missing dimensions. It already tells us that this cone has a volume of 50 and a height of 6, and it wants us to find the radius. So if we plug in those values into our formula, we know that V equals 50. 1/3 pi won't change. We don't know our radius, and we know that our height is 6. Now we need to rearrange this formula using algebra to solve for r. So in order to do this, my first step is going to be to multiply 1/3 times 6. So I'm going to rewrite this. 1/3 times 6 gives me 2 pi radius squared. My next step will be to get rid of my 2 pi, so I'm going to divide by 2 pi on both sides. So I'm left with r squared is equal to 50 divided by 2 pi. Now my last step is to take the square root of both sides. My radius is the square root of 50 over the square root of 2 pi. Now you can plug that into your calculator and get a decimal, or you can also leave your answer like that. For the sake of neatness, I'm going to leave my answer like that. The next problem is asking us to find the volume of this composition figure. Now, if you notice, we have two shapes. We have the cone on the top, and we also have a cylinder on the bottom. Now, in order to find the volume of this entire figure, we must first find the volume of the cone, and then find the volume of the cylinder, and then add them together to get the volume of the whole figure. So, the first thing I'm going to do is find the volume of the cone. And then over here, I'll find the volume of the cylinder. And at the end, we'll add them together. So we know that the volume of a cone, the formula is 1/3 pi r squared times your height. So in this situation, we have 1/3 pi. Our radius is 2 squared. And our height, just of our cone, is 4. Now, if we want that in terms of pi, I would get 16 over 3 pi. That is the volume of my cone. Now, if we go over to volume of a cylinder, our formula for volume of a cylinder, if you recall, is pi r squared, because that is my shape of my base, so I need to find the area of that base, times h. So essentially, pi r squared is my big B, because my base is a circle, and the formula for area of a circle is pi r squared. So my radius of my base is 2 pi times 2 squared, times the height of my entire cylinder is 5 inches. So that means the volume of my cylinder, in terms of pi, is 20 pi. Now, the last step to find the volume of the entire composition figure is to add these two volumes together. So my entire volume is 16 over 3 pi plus 20 pi, which gives me 25 1/3 pi. That's in terms of pi. Or if you multiply 25 and 1/3 times pi in your calculator, you will get 79, rounded to one decimal place, 79.6. And our units would be inches cubed. So both of these answers are the same and both are correct.